Alrighty guys, we're going to go ahead and get started with this Ohm's Law Manipulation. So first question says, a student builds a simple circuit with a single resistor of resistance R2 and measures an electrical potential of delta V across the resistor. Then the student replaces the resistor with a new one of R over 2 and keeps the electric potential difference the same. What is the current I2 through the new resistor in terms of the original current I1? So what I recommend is that we identify all the parts that are in the initial circuit. So that would be delta V is equal to that initial resistance, which is 2R, times that first current, which is I1. After we identify the first one, we need to identify the second one. And the second one also is delta V because it says that they keep the electrical potential the same. And now instead of R being 2R, it's now R over 2. And then our new circuit has a new current, I2. It's asking us to figure out how these two currents compare to each other. So in order to do that, we need to find out a way to combine these two equations. So we're going to go ahead and use substitution. We know that the potential difference, delta V, is the same in both of these cases. So we can just set these two equations equal to each other. 2R times I1 is equal to, and again, since these delta V's are equal to each other, this 2R times I1 is equal to R over 2 times I2. Our final answer should be in the form of just I2 equals some number times I1. So let's get I2 by itself. To do that, we're going to multiply the 2 over and divide by the R. So we get 2 over R, because we're multiplying this part over, times 2R times I1 is equal to I2. The R's cancel out and we're just left with 4 I1 equals I2. And we can see our answer right here. Let's go ahead and move on to the next one. So this next question is very similar. It says a student builds a circuit again with a resistance 2R, measures the electric potential difference of delta V1 across that resistor. Then the student replaces the resistor with a new one, R over 2, and they keep current the same. So this time current's the same. So let's go ahead and write our two equations like before. We have delta V1 is equal to I times 2R. And this equation is just Ohm's law over here. I'm just plugging in my variables. And then our other one is delta V2 is equal to I, because it's the same current, times R over 2. So instead of us just setting these equal to each other right away, we need to do some manipulation. The variable that's the same in this case is current. So we need to solve for current on both of these. So if I solve for current in my blue equation, I get delta V2. I divide R over 2 over to the other side. So I get times 2 over R is equal to I. And then I simplify my other equation and manipulate it, where I get delta V1 divided by 2R equals I. Now that these I's are equal to each other, I can just set them equal. And that gives me my new equation, which is delta V2 times 2 over R is equal to delta V1 divided by 2R. Now we just need to solve for delta V2 like we did before. So we'll multiply this R over and divide this 2 over here. It's going to give us delta V2 is equal to delta V1 divided by 2R. And then we multiply the R on top, so we got R up here, and we divided the 2 on the bottom. These R's cancel out again, and we're just left with delta V2 is equal to 1 over 4 delta V1. So 1 over 4 is 0.25. And here we go. There's our answer again. Let's take a look at our next problem here. Student builds a simple circuit, just like before, with a resistance R, measures the electrical potential difference of delta V. Then the student replaces the resistor with a new one. This new resistor is R over 2 and keeps the electrical potential the same this time. So that's important. We need to identify what part's the same. So if we write our equations just like we've been doing, we get delta V is equal to R times I. And then if we look at our other equation, we get delta V is equal to R over 2 times I2, because these currents are different. Now, since the delta V's are the same, we can just combine these like we did before. So basically, when we say combine, we're just substituting the R times I in for the delta V over here. That gives us R times I1 is equal to R over 2 times I2. We want to solve in terms of I2, so we're going to divide R over 2 over the other side. That's going to give us R divided by R, and then the divided by 2 goes on top over here, times I1 is equal to I2. Therefore, R's cancel out. We're just left with I2 is equal to 2 times I1. Let's take a look at our next problem down here. A student builds a simple circuit just like before, so these are all the same thing. This time we have a single resistance R and current I, and the measured electric potential of delta V1. So I'm going to write that down, delta V1, I times R. Then the student increases the current to be 2I, okay? But they are keeping that resistance the same. So delta V2 is equal to, in this case, 2 times I times R. So what part of this circuit is the same? Well, the resistance is kept the same. So we need to manipulate these equations to solve for resistance, and then we can plug it in. So if I take my red one, I get delta V2. In order to get resistance on its own, I got to divide both sides by 2I. So I do that, and that equals R. Then for my blue equation, I do the same thing. I get delta V1, I divide by I, and then I get R. Now that both of these equations equal R, I can set them equal to each other, and I find out that delta V1 over I is equal to delta V2 over 2I. I still have these I's over here, and I want to solve for the delta V's, so I'm going to multiply my 2I over the other side. So take this guy, multiply him up here, and that's going to leave me with 2I divided by I times delta V1 is equal to delta V2. We're going to notice that our I's cancel out here, and we're just left with delta V2 is equal to 2 times delta V1. And that answer is right here. So last problem, we have the simple circuit with a single resistor R and current I, and it measures an electric potential of delta V1. So let's write that again. Delta V1 is equal to I times R. All right, and then this time, instead of us increasing that current, we're actually going to decrease that current to be half as much. So delta V2 is equal to I over 2 times R. You're going to notice that we didn't change the resistance again, so we have to do what we did before and manipulate our equations to solve for R. So I get delta V2 divided by, I divide I over 2 to the other side. It gives me I, the over 2 goes up to the top, and I have delta V2 times 2. It's equal to R. Now I solve for my other equation. Delta V1 is equal to, divide the I over, so delta V1 over I equals R. I have R over here, I can set them equal to each other just like I did before. Delta V1 over I is equal to 2 times delta V2 over I. I can go ahead and multiply my I over, so I multiply this I over here, over the other side, and then divide my 2 over the other side. That's going to leave me with I times delta V1 over 2I, which equals delta V2. The I's cancel out, and I'm left with delta V1 over 2. In other words, delta V2 is equal to 0.5 delta V1. So when you guys are doing this, I highly recommend writing down your information. And all we're really doing here is just finding something common in both of these equations and substituting it in to the other equation.